Hello everyone, Victor here. It's 15th of October and it's time to solve the 15th Leetcode challenge. It's called Rotate Array. Rotate Array. Given an array, rotate the array to the right by k steps where k is non-negative. Follow up. Try to come up with as many solutions as you can. There are at least 3 different ways to solve this problem. Could you do it in place with O1 extra space? Okay, I mean that sounds like a pretty trivial problem, but let's try to think about it a little bit. Right, so what does rotate mean? I mean I'm assuming, so I should confirm what I'm assuming to begin with. So rotate k3 means 7 needs to come here, then here, then here. Then 6 needs to come here, then here, and here, and then 5 needs to come here, and here, and here. So it's basically 5, 6, 7, and then the rest 1, 2, 3, 4. So obviously the easiest solution is to just slice it. So let me get my Paint 3D going on. Let's say I have this exact problem. So my array is 1, 2, 3, 4, 5, 6, 7. Okay, this is my array. So what I'm saying is, if I just slice the array up, so I slice it from the back end 3 times, so 1, 2, 3, and then here I slice it. And then I can just create a new array where the array starts with the right slice, so 5, 6, 7, and then ends with the left slice, 1, 2, 3, 4. So this is one way to solve it. Create a new array and slice it. And there is one small caveat. So let's say that k is like 55. I mean, if I slice it 55 to the left, then I'll have an array out of bound exception. Right, so instead of slicing it 55, calculator. Instead of slicing it 55, I need to take the number of elements I have. So how many elements do I have? Like 4, 5, 6, 7. I have 7 elements. And then basically do a division with remainder. So modulus or whatever it's called in English. I always forget the percentage one. So do that to find out how many times do I need to slide it over, since if I have 7 elements and I slide it over by 7, then it's gonna be the exact same input, right? So instead of doing some bullshit, I can just take the remainder of 55 divided by 7 and yeah, shift them that many times. So what's that? So 8 times 7 is 56, right? So 7 times 7 is 49. I'm really bad at this. Yeah, it's 49. So this means that my remainder is 6, right? 55 minus 49. So this means that if I had the 55 as input argument, I'd need to shift 6 times. So I'd have like just the 1 to the left. So like shift everything from the 2 from here. So 2, 3, 4, 5, 6, 7, and then 1. And this would be my entire array. But that would be if k is 55. So that's all I need to care about, if k is higher than the number of elements I have. And I should have probably checked the constraints first, but yeah, so num's length, it's always at least 1, and it's 2 to the times of 10 to the 4th. 2 times 10 to the 4th. That's not that many. And then the elements themselves are integers, and k is from 0 to 10 to the 5th. So yeah, I can actually have a k. Can I? I think I can have a k higher. Yeah, I can have a k that's higher than the number of elements I have. So yeah, my first assumption was this, but this one can never be O of one space, because doing this automatically means I'm assigning an extra array. So extra array means on of space. So let's try to figure out an O1 extra space solution. I mean, there are probably a lot of solutions. I really can't be bothered to think of all of them. But the easiest one I can think of is still to do the modulus for between number of elements and k, but then just shift the elements that many times. Like, I can shift every element that many times. So let's say I want to shift them 3 times again. So what this means is I can just say 7, you come here. I mean, I guess it would be nicer if I write it like that. So 7, you come here, which means that 1 goes there. And then 6, you come here, which means 2 goes there. And then 5, you go here, which means 3 goes there. So this would be O1 of space, right? Since I'm just swapping some elements. It's not as easy as I made it seem, but it's kind of that. Basically, without allocating any extra memory, I need to actually shift every single element to the right. So like shift 1 here, shift 2 here, shift 3 here, 4 here, 5 here, 6 here, and then 7 all the way here. So I need to do this k times, and in order to be a little bit more efficient, if k was like 55, which we already know is actually 6, then I can just figure out that it's 6 times, so I can do this whole operation 6 times. And this would be O of n runtime, O of k runtime, I guess, k times n actually, right? Since I'm moving every single element, which is n elements, a k number of times. Well, k modulus, whatever I have the number of elements. So this would work, I'm pretty sure. I just do this a bunch of times if I don't want to allocate any more memory. I mean, I would much prefer to have the previous solution, but if you want to do O1 extra space, then this would do just nicely. So let's try to code it. So what is this? This is 15. Yeah, it's 15. Let's go. Let's go 15. Let's copy the boilerplate. And go from here. So I'll have a rotations is k by num's size. So the remainder is how many times I need to shift it. And then how do I shift it? I guess I can have a method that just shifts 1, and then I run that method k times. I mean rotation number of times, right? So how do I rotate them a single time? I'm just gonna say Kotlin really sucks at this, right? Because I can't have for cycle, regular for loop. But I can have index that starts from 0, and then I can say while I is less than nums dot last index minus 1. Then I'm just gonna have temp is nums I plus 1. So I'm just gonna swap them. I mean I want to progress them. So I basically need to just remember the last element. What was the last element? Right? I need to remember what the last element is. That's all I need to do. So last element is nums 0. I mean it starts from num 0. And I'm gonna say then I guess I can just say I start from 1, right? So I can probably have a regular for loop. So for I in 1 until elements, nums last index. And I don't need this. What I'm gonna do is I'm gonna say val temp is nums I. So now I have nums 1 here, for example, and I'm gonna say nums I equals to last element, and then I'm gonna say last element equals temp. So I'm just swapping them, right? Where is my paint? So I'm saying here last element is 1, start looping through them, through all the indices, and then temporary is index of I, which is the 2. Then I'm saying nums I is last element, which is the 1, so 1 comes here, and I'm saying last element equals 2, and I'm just repeating this all the way until I get to 7. And when I get to 7, I need to do it one more time, and I need to say that this comes to the beginning. How do we do that? So when we're already at I equals last index, so I is here, what we're gonna say is temp is this, then this becomes 6, then last element becomes temp, so temp becomes 7, so last element becomes 7. So we just need to say at the end nums 0 is equal to last element. So this is the entire algorithm, and we basically repeat this k times. So it will be like repeat rotations, the entire thing. No, not this. This. And that should be like actually the entire thing. So let's try it out. Let's try with the exact example we have here. So this. Let's go rotate and then int array of this thing, whatever it is, and then k is what? K is 3. But this needs to be outside, and then we're just gonna say nums for each print it. Oh, I guess it and comma. Let's see what happens. Can we see what happens, please, IntelliJ? Come on, IntelliJ. This is so simple. This should take like a fraction of a second. Thank you. So 5, 6, 7. 1, 2, 3, 4. Okay, I think I like this solution. Let's see if it works. It might not work. I might have forgotten something, but it sounds reasonable. And it's 1 of extra space, since we're not using any extra space. So if it works, I'm just gonna be happy to take it. And it works. Okay, amazing. So let's check the other solutions to see what they're doing. What did I just click? I just want to see the discussion of the other solutions. So I guess this is the proper way to do it. Easy to read Java solution. What do you do? So you take k and then you say k % equal. So this is the same, that's what we do. Then you say reverse. What do you mean reverse? I guess I have to read this first. So what does reverse do? It takes the array, start and an end, and then it says while start is less than end, then temp is start, start is end is temp, start plus plus and minus minus. So just gonna like flip them all the way around. So just flipping them. So he's flipping them once, like for every n divided by 2 number of times, since it's both doing start plus plus and then minus minus. So it's taking them from both ends and then reversing them, thus reversing them. And then he does another reverse, but this time 0, k minus 1. So k is already the modulus 1. And then he reverses them again. I mean, why would you say that this is easy to read? I mean, I guess it works, but it's not easy to read. Come on, please. Let's find another one. Somebody. So this one is if it's 0 or whatever return. I mean, this makes sense. We could have done this optimization as well. Make a copy of num. So he does a copy and then he will say, this is the copy actually. And then he rotates, meaning nums I plus k percent n equals nums copy I. All right. So this is the n space complexity because he has to do the copy. This is the initial one that we had there. And then he says, start from one element and keep rotating until you have rotated n different elements. This is basically the same thing we do, right? But, okay, I mean, I didn't actually read it, but it sounds like the same thing with just a lot of extra steps. Okay, actually, I really don't want to read more of this. This solution, this problem is really not that interesting. It just, you need to imagine that your array is actually connected. So basically, it's up to you to decide how you connect it. So it's like a circle instead of an ending array. So there are some interesting things you can do when you present an array as a circle. Like there is this thing called a circular buffer. Which is quite interesting and kind of commonly used, and it's just an array structure that is presented as a circle, and then you have the array deck in Java, which is not really a circle, so I guess I'm stretching it out a little bit. There are some cool implications to that, but all we know, this rotate array thing is not a very interesting problem in my opinion, so it's not really worth thinking too much about it. Just as long as you know a way to do it, then you're good to go. And as always, if you have any questions, I'll be very happy to read them in the comments. Currently, the videos, actually, since I'm not marketing them at all, have an average of 1 view, I think. 1 view, maybe, per video. Or 0, I'm not sure. I think it's more leaning towards 1. So this means that if you are by any chance watching this video, you'll be the only one. So if you have any questions, I can respond to them. Otherwise, then Victor in 2 years will be happy to see this. So there's that. Thank you so much for watching and see you everyone tomorrow.